Our discussion of calculus this semester begins with the idea of limits, but before we even get into talking about limits, we want to just look at the graph of this function, which we'll refer to as f of x, and talk about some of its behavior and characteristics that we can just identify before we even introduce any new concepts. To start off, we'll look at what's happening with our graph near x equals -1. If we start at x equals -1 and trace up until we hit the curve, we'll see that we hit a function value of 4, meaning we could say in this case that f of -1 is equal to 4. That tells us that our function is defined at x equals -1, and we have a function value, which is 4. We can also notice that at -1, our function is smooth and continuous. That is, we could trace along the graph, at least at this portion, without picking up our pen because there are no breaks or jumps in the curve. And furthermore, we could look at what happens as we trace along our curve, specifically from the left. As we do that, we get closer and closer to that function value of 4. And as we trace along our curve from the right, again, we get closer and closer to that function value of 4. At a glance, you can probably tell that that same type of behavior won't be consistent at all the points we're going to consider. So let's look at what's happening at x equals -4, or near x equals -4. Here we have a break or a jump in the graph. We refer to this as a jump discontinuity, because if we were to trace the curve, we would have to pick up our pen or pencil and then jump to a new spot to continue tracing that. What we look for is a filled in dot, which tells us where our function is defined, versus the open dot, which is below the x-axis, telling us our function's that's not our function value. So we can state in this case that f of -4 is equal to a function value of 3. And now if we consider tracing our curve from the left-hand side, we see that we approach that function value of 3. But if we trace our curve from the right-hand side, we're approaching a different function value. We're getting closer and closer to y equals -2. Now let's take a look at what's happening near x equals 2. Again, we have a jump discontinuity. We look for that filled in circle to tell us what our function value is. So in this case, we could state that f of 2 is equal to -1. And we could consider that behavior as we approach from the left-hand side. In this case, we see that we're approaching that function value of -1. Whereas if we approach from the right-hand side, we're getting closer and closer to a y value of 5. Now finally, what we'll look at, our last point, is what's happening around x equals 4. At x equals 4, we have what's referred to as a point discontinuity, because other than this one point, for instance, if we were to fill that in, our function would be smooth and continuous. We could trace along it. But since we have that missing point, we have this point discontinuity, to draw this or trace this, we technically have to pick up our pen or pencil, jump over that point, and continue on the other side. Since all we have is an open circle at x equals 4, we would have to say that f of 4 is undefined. In a similar case, we could have a point that's disconnected from the rest of the curve. If so, we would say the function is defined and that was our function value, but we don't have any filled in circle in this case. So we just say that our function is undefined. And then we can consider that behavior as we approach from the left and the right. In this case, regardless of which direction we approach from, we're approaching a function value of 2, even though the function is undefined there. Next, what we'll do is move on to introduce the idea of limits and then revisit this graph to add the limit concept to what we've already mapped out here.